Okay, so today I'm going to be discussing the ethics of gene editing versus the benefits. So, by a show of hands, how many of you have heard the term designer babies? It's actually more than I thought. In short, designer babies is a term that is used to describe babies who have been improperly and unethically genetically modified for the purpose of outward trait correction. And an example of this is parents choosing to genetically modify their unborn child so that their baby can have blonde hair and blue eyes. Not only is this unethical, but it's also selfish. But the good news is, however, gene editing is mostly used to create is not used to create designer babies. But I'm getting ahead of myself. So, starting with the definition of gene editing, what is gene editing exactly? Gene editing is a type of gene therapy, which gene therapy is a medical technology that is used to produce therapeutic benefits. But by definition, gene editing is the alteration of genetic material um, of a living organism by inserting, replacing, and deleting a DNA sequence, typically with the aim of improving some characteristic or trait of a crop or farm animal or correcting a genetic disorder. So recently, researchers have made progress on the future of gene editing in the realm of disease eradication control. Gene editing has the possibility of eradicating most birth defects and benefiting those with deadly genetic disorders. So, Julian Savulescu, a director at the Center of Biomedical Ethics at the National University of Singapore, states that 6% of children are born in the world with birth defects. And some examples of birth defects are heart defects, Down syndromes, sickle cell disease, and much, much more. And additionally, Savulescu reports that 35% of all deaths are due to chronic diseases. And chronic diseases, if you don't know what those are diseases that are persistent and long lasting with their effects. So it's basically a long term disease. Some examples of chronic diseases that also place among the top causes of death in the world are heart disease, cancer, strokes, and Alzheimer's. The CRISPR technology, which is the technology used to modify a patient's genetic code in gene editing, could benefit people worldwide by alleviating pain, discomfort, and potential insecurities from chronic disorders and birth defects. And researchers hope that gene correction will be permanent, but they have no idea if the trait will be passed down to future generations or not. But the permanence of gene correction also raises many questions, such as, do we know enough about human biology to confidently predict all the consequences of such modifications? Are the procedures safe enough, or will they induce unwanted mutations or consequences? And will the technology be able to be used to attempt enhancements? So this means like greater intelligence, athletic prowess, and attractive physical features rather than the disease treatments. So this is also known as designer babies. So ironically, these questions provide us with the answers, which means more research, more lab tests, more trials, and ultimately time is needed to tell. Recently, on December 8th, 2023, the FDA approved the first gene therapy for sickle cell disease. And for background, sickle cell disease is an inherited blood disorder that impacts nearly 100,000 people in the United States. And in sickle cell disease, hemoglobin, which is a protein found in red blood cells, delivers oxygen to the tissues, and it mutates, causing red blood cells to have a crescent shape. So if you look right here, these are the sickled red blood cells, and they ultimately end up blocking the passage of the blood so that the blood can't reach the tissues. And Casgevy, which is the first type of gene therapy used to treat sickle cell disease, uses the CRISPR-Cas9 technology to cut DNA in targeted areas, enabling the ability to cut DNA. The ideal outcome of Casgevy is that these modified blood stem cells are implanted back into the body, where they attach and accumulate on the bone marrow, increasing overall production of hemoglobin. And in a trial with Casgevy, a total of 44 patients were treated, but of the 31 patients with sufficient follow-up time, 29 achieved successful engraftment, which is the positive growth of previously implanted blood cells. So that means that they begin to grow and produce healthy blood cells. So, and the ultimate cost of Casgevy is $2.2 million, but it's a one-time treatment. The second approved gene therapy is called Lyfgenia. Lyfgenia modifies a patient's blood stem cells to produce a gene therapy-derived hemoglobin that is similar to the hemoglobin that is produced in a person's blood with sickle cell disease. And in a trial with Lyfgenia, after 6 and 18 months of infusion, 28 out of 32 patients achieved VOECR during this period, and this means that the patient's vaso-occlusive crises, when blood cells block the blood flow into the tissues and the blood tries to rectify the issue, it has been resolved. So the cost of this gene therapy is $3.1 million. And despite the astronomical cost of these gene therapies, the patients that were treated with Casgevy and Lyfgenia have no symptoms of sickle cell disease since the completion of their one-time treatment. So in October of 2018, a scientist by the name of Hei Jianqiu successfully edited the genome of baby twins, which you may have seen in the news. He disabled the piece of genetic code that would allow HIV to enter the body, making the twins immune to HIV. However, the scientist executed his experiment in secret without any approval or oversight from any doctors or researchers. And his goal using the CRISPR technology was to prevent any subsequent risk of HIV infection in babies when their father was HIV positive. On November 25th of 2018, the genetically engineered twins were born and named Lulu and Nana, as you can see to the left. The birth of the gene editing of these twin girls sparked countless ethical and legal debates. So, for instance, gene editing can have a large effect on something very small, and editing a small part of a person's genetic code, while seemingly harmless, can have a large effect on a person in the long run. Gene editing researchers from the US and UK expressed that gene editing should only be done to address serious unmet medical treatment needs, and it has to be well monitored, well followed up, and put in full consent. In 2018, China had not put any legal restrictions on gene editing, but in February of 2019, China banned all gene editing for reproductive purposes, and the US and UK have done the same. And Dr. He has been disregarded as a scientist and disgraced as a doctor in China because of his unethical and unmediated practices on the human genomes. And selfishness basically corrupted the mind of Dr. He. And in March of 2019, Hafiz Abdul Rahim Salim, a Chinese researcher at the Public International Law and Criminal Law, claims that just like absolute power corrupts absolutely, the persistence of a similar non-cognizance of any human gene editing and further development of embryos to any mature human can cause unpredictable consequences. So in general, Salim is deliberating that by allowing doctors and researchers to conduct unethical experiments, unforeseen consequences can and will occur. So a growing concern with gene editing is the overall cost for treatments. Many families seeking gene editing as a solution to a life-threatening disease often do not have enough funds to afford a single treatment, which brings us to the question, why are life-saving treatments so expensive when human beings can't control what disease they have or don't have? So let's look at the 4 reasons for high prices for gene therapies. Firstly, the clinical benefits of the treatments justify the costs. As we have seen in the gene therapies, Casgevy and Lyfgenia, the patients have had no symptoms of sickle cell disease since the completion of their one-time treatment. So this is seemingly cost-effective. And secondly, the doctors are performing gene therapies and research and subjecting themselves to a great deal of danger. For example, dangerous machinery and deadly diseases that they're experimenting with. Thirdly, there are only 2 gene therapies on the market, which are Casgevy and Lyfgenia, allowing the companies the ability to charge whatever they want because there are no other competitions. Fourthly, doctors, researchers, and scientists deserve a great deal of compensation as they're contributing to a life-changing discovery and treatment, as these diseases are incurable at the moment. And then the cons for high prices of gene therapies are as follows. 1, it limits who can afford the gene therapies, dividing who gets access to life-saving treatments. So essentially, rich people are the only ones who can really afford this. 2, doctors can easily exploit their patients. The large price of these gene therapies can cause doctors to care more about the price rather than the well-being of their patient, especially when considering like a capitalist versus socialist economy. So what does the Bible say about gene editing? And the first question that comes to mind is, does gene editing interfere with God's perfect design? And when looking at Genesis 1:26 through 27, God explains his intention and design of man. He created man in his own image, perfect and unique, and man was also given dominion over all creation and be told to be fruitful and multiply. So when considering gene editing, how can a medical procedure correct a man that was already made in the image of God? The answer is it can't correct God's design. However, after Adam and Eve sinned, the world was introduced to sin, and everything created or brought into the world after the fall was considered to be affected by the fall. In general, gene editing, the CRISPR technology, is to be used to cure previously incurable genetic diseases, and these diseases, in fact, all diseases in general, are a direct result of the fall. So, to entirely answer the recent question, gene editing is not correcting God's design, but rather reducing and eliminating the effects of the fall. So, essentially, when God created man in his own image, sin corrupted the world, and God did not create the world with the intent for man to live a disease-ridden life. So the fall of man caused man to face the consequences of sin. Consequently, God ordained disease to be one of the consequences of sin. But there's good news, because God is the healer of all things. He would not give us a disease in the world if there was not a way to cure it, whether that is God through man or by God himself. So the second question that comes to mind when considering gene editing is, what is a person known for? So the Bible constantly preaches that the outward appearance is not what matters most, it's the inside that is most valued. For example, in Matthew 12:33, Matthew details through a visual metaphor that either make the tree good and its fruit good, or make the tree bad and its fruit bad, for the tree is known by its fruit. This verse declares the idea that people are known by the fruit they bear, which is their actions. Gene editing emphasizes the idea that people are known by the common population values being perfect or looking good rather than being valued by your actions. So as children of the Lord, we are called to be servants of the Lord, to serve him unconditionally, no matter our flaws or indiscretions. So one of the issues with gene editing is the idea that a person needs to be made perfectly to fit society's standards. And aside from gene editing being used for treating genetic disorders as a result of sin, gene editing could be used for selfish desires. So a person, when given access to the CRISPR technology, can modify genes to fulfill their agenda or desires, because human nature is naturally selfish. And not only does this directly contradict the Bible, but also contradicts the unspoken ethical rules that people have put in place for matters like these. So how does this apply to me? Well, next year I plan on majoring in biomedical engineering at Clemson. And basically, if you don't know, biomedical engineering is medical equipment engineering. So I could be engineering the equipment being used for gene editing, or any equipment in the medical field, or I could even be doing the research for gene editing itself. That's it.
And I love that these two went right next to each other, because I get to ask this question. All right. Let's say, theoretical, this is a case study. Gene editing is $5. For $5, I can ensure my unborn child's frontal cortex will fully develop, so that way they'll have increased higher functions.
Mm-hmm.
Would that be ethical?
I would say no, because that is more a cosmetic surgery rather than a genetic disorder surgery to correct that genetic disorder. Because if you don't know if your child is lacking in any of those frontal lobe cortex stuff, whatever you're talking about, you don't know if your child is going to lack in that by any tests in the embryo. So I would say that's more as a selfish desire of the parent to ensure that their child is at like top quality, essentially. Like your child has like the most developed frontal cortex as possible. So I would say that's unethical.
Could I say like it's selfless? Like, why is it unethical to say I want them to have a fully high functioning brain?
Because
that way they could be best equipped.
I would say because we, as children of the Lord, and because of the fall of man, we're created in God's image, but we're not created we're created perfectly, but we're not perfect people. So by editing like someone's genes so that they are fully developed in their brain or will fully develop with all the traits of the cognizance. Um, that's more of trying to play God rather than like genetically modify an incurable disorder. Does that make sense?
So it seems like there's a pretty significant difference between there's an existing problem that I know my child might be susceptible to um, versus just trying to procure the best standard of living possible.
Mm-hmm.
So, that's why I'm like kind of jumping in on this because my question, um, there seems to be two components to this. There's the sciencey component of what we can do with biomedical technology,
Mm-hmm.
and then there's the philosophical component, the ethical component of what we ought to be doing with this technology.
Mm-hmm.
And so you mentioned that you are looking to go into this field. Trying to figure out like I think I know the answer to this question, but I want to get your take on it. How much of a priority do you think it ought to be in the program you're about to enter into? What did you say the program was?
Biomedical engineering.
Okay, in the biomedical engineering program at Clemson, what do you hope they offer in terms of? I'm assuming they're going to train you scientifically, like teach you how to do all of this stuff. How much training, given this project, how much training do you hope that they give you in terms of thinking through the ethical implications of it?
I'm pretty sure there's a class based on the ethics of biomedical technology. So I don't know if I'm wrong or right. I'll have to fact check myself on that. But I would say it is extremely important to have the education of the ethical concerns of biomedical technology because it can be easily corrupted. So it's something when put into the hands of the wrong person that it can be turned into something very, very bad. But the ultimate goal is to use it for something that is very, very good, just like anything in the world. But I would say I hope to be educated a lot on the ethics of biomedical technology.
So I say that because, oh goodness, Katie Brookins did her project on it, and it's awesome. Like hearing several of y'all do projects on the same topic and the different directions you're coming at it from. Like everybody's research is different, everybody's angle is different. You considered the ethical side of things from money, like you went deeper in your paper about the monetary side of all this stuff. And she came at it from the perspective of, or from a different perspective. One of the things that she did was, and this is a follow up to everything you're saying, not saying like they just coalesced really well together. She interviewed a professor in, I think it was, I don't know if it was biological engineering per se, but it was something along those lines. Like she's, PhD in biomedical whatever, and so she knew everything there is to know about gene editing, where the technology is right now, like what's going on. But as a professor who teaches this stuff, number one, she has received no training in ethics. She never took a class on it in all of her 14 some odd years of higher education. She never took any bioethical classes. Nor is she terribly interested in teaching it, because that was Katie's question. Was like, well, would you? And she said, I don't really see the need. Meanwhile, she also talked to a PhD candidate, so he's not quite there yet. But he recently, between I want to say his grad work was all the biochemistry, like all the engineering side of it, but his PhD is now just in bioethics because he sees a complete lack of ethical considerations in all this. So like I'm really excited to see you understand how cool the technology is and how promising a lot of it can be, but going into it with the understanding that all of this underneath all of this underlies all of these really, really significant ethical questions. So it's like keep that in mind as you go through. Yes, sir.
Are you okay with this? Can I jump to animals? I don't have a soapbox on this. It's just fascinating. What are thoughts on genetically modifying animals?
What do you mean? Because there's different ways you can take that.
Yeah. So on the agricultural side, if you could genetically modify chickens so that way they were more disease resistant.
Mm-hmm.
Yeah or nay?
Probably nay, because if it's disease prevention, like of a disease that is easily curable, I would probably say nay. But if it's like an incurable disease that we see in their genetic code and their traits before like the chicken is hatched, I guess, then I would say yay, because that is something that they can't control. But if it were something like easily like, I don't know, chicken diseases, but like the flu, like if it's something like that, probably not. But it depends on the severity of the situation rather than the.
What about like genetically modifying pit bulls so they're less violent? Like, do you see what I'm saying? Like, designer pets
Mm-hmm.
are a thing. Like, they're gonna be a thing.
Mm-hmm.
But it's just dogs.
Yeah, but I would still consider it unethical because you're taking away like the ideal design of God's creation, because pit bulls are naturally more aggressive rather than like golden retrievers. So I think that's just like a natural trait of theirs rather than like an inherited disorder.
So I was thinking something related to that, and then this is just, again, a question. Has there been a situation where, again, research is so limited and we've done so little in relation to it, but any kind of the testing where we've seen it was effective in preventing what it was intended to prevent, but it ended up making the patient more susceptible, whether that patient's an animal or human or whatever.
Mm-hmm.
Has there been a case yet where, yeah, it took care of the problem we were aiming at, but now it's created this unintended consequence over here? Because you mentioned like that's a big concern. Has there been a solid, like concrete instance of that?
Since it's fairly new, there hasn't been like enough time to really tell if there is any unintended consequences, and they like doctors and researchers still currently don't know if the trait will be passed down to, like, if you genetically modified someone and then they had kids, we don't know if the trait would still pass down from like that person's parents.
Right.
So it's just time.
And
There's
a
need
lot
more
of the,
research.
if I recall, a lot of the tech, keep calling it technology, a lot of the procedures are intended for generational consequences. Like this is a hereditary thing that this particular family is dealing with. The sickle cell thing, for instance, is highly hereditary. So, like, if we can cut this out of the bloodline, for lack of a better term, but there have been instances where, yeah, but that ended up rendering the animal, anyways, it ended up rendering them infertile. So, like, what you intended to do, you actually ended up, preventing altogether. So, it's tricky when you get into humans. All right, classmates, we got a few minutes. Y'all got anything for Kate or Davis for that matter? Y'all got any questions?
I don't know questions, but like say, because it's like super expensive, so like 99% of people won't be able to do it.
Yeah.
But say it was something like say $100, so like pretty much everybody could do it. Would that like change anything sort of?
100%. Because like I said, human nature is naturally selfish, and they would rather get the gene therapy so that they can prevent a genetic disorder that they don't have. So it would like open up a whole another like can of worms, and it'd be really, really awful to see. But it could happen in the future. Like we could see something like that happen in the future because we don't know what the future holds. But if something like that were to happen, I think it would be exploited rather than used for benefits. So
I think on that, something interesting to me, like hearing your project is like, I think it'd be interesting to note the correlations between this and say plastic surgery. Plastic surgery was developed for burn victims, for people who just, they had these problems. So we had skin grafting, we had all these different things and even like amputees would be able to have reconstructive surgery and all this kind of stuff. And and then we got this really superficial reason for plastic surgery that now is creating all these other problems of, your body dysmorphia and like people literally getting addicted to surgeries because, hey, I gotta keep tweaking and keep making the, so like, that's the ethical consideration is what are all these unintended consequences and how do we navigate through the positive? There are certainly positives. There are certainly things where this seems, this could cure cancer if we play our cards right, but that's all part of it is trying to figure out how to play the cards right. Got anything else?